Okay, so with part A, we've got two approaches. Okay, so we could take logs. Okay, so we remember taking logs of both sides. So I've got log 3 to the power 5x over 4 minus 2. Quite a complicated looking power there. Equal to then log of 7 on the other side. Now in terms of the base, remember now, we'll just use base 10, right? Because it's simpler. We don't have to write 10 then, okay? So it doesn't matter what base you choose, actually, okay? Because you're doing the same to both sides, aren't you? You're taking logs to both sides, but choose base 10 because it's easier, okay, to write it. Now, what I do then is, because you've got a power, you can bring that down in front of the log. So we get 5x over 4 minus 2 log 3 equals then to log 7, okay? Take that log 3 then over the other side, okay, because you're times in that bracket by log 3, so take it over the other side. So it becomes log 7 over log 3. That minus 2 then needs to shift over. The other side becomes a plus 2. And then we just got to deal with this 4 and 5 fourths then, okay, so we take the 4 over and times, take the 5 over and divide. So we'll have a bracket 4 over 5 log 7 over log 3 plus 2. Okay, so on my calculator, I got x comes out to be 3.017, okay, to 3 decimal places. So that's, that's the way we do it by taking logs. The other way, of course, is just swinging the base there, okay. So you get it as a logarithm straight away, okay. It's your choice to see in terms of why we get the answer. Part B then, it says the positive numbers a and b are such that log to the base a of b equals to 5, okay. It says then express b as a power of a. Well, we know that, don't we? Because all you do here is appreciate the logarithm is equal to the power, and a is the base, isn't it? So you swing the base, get rid of the logarithm. Then when you swing the base over the other side, the logarithm goes, so you've got b equal to then the base to that power. So b equals a to the power 5, okay? Alright, so that's part 1 there. Part 2 then, it says, use your answer to part 1 to evaluate log base b of a. Now, notice what we've got here. They've made now b the base, okay? So if b is the base, if you think about it, it needs to have a power, yeah? So I need to use now what I've got from part 1. So I've got the solution from part 1, but just just think about that for a minute now, that I want b to be my base, so I need b to have a power. So b hasn't got a power at the moment, the power is here. What I can do is I can take the power over the other side, can't I? So that power 5 that I can take over, but remember, when you take it over, you do the opposite. So the opposite of power 5 is the 5th root, okay? So you'll have fraction 1/5 essentially equals to a. And then what I hope you realize is you've got your base to the power equals this, yeah? So we can create a logarithm, okay? Base to the power equals this. Well, we can swing then the base over to create a logarithm. It will equal then that power, okay? Well, it'll be logarithm to the base b of a. So logarithm to the base b of a will equal to 1/5.